Hey guys, okay, so for my transmissions project, I ended up doing the NV271 transfer case, and it was a little challenging at first because of the fact that I kind of wasn't 100% sure what I was going to talk about, and then after getting the gear shifter motor, I kind of fell into place, and I ended up focusing mainly on that. Which you'll kind of see in the rest of the video.
Alright, so we're going to jump right into this. One of the most fun parts that I had with this particular project was the fact that I got the chance to actually take apart and kind of try to understand a circuit a little better. For the most part, as a technician, you get the basics of how things work, and once you've determined electrically whether or not a module is bad, you usually just end up replacing the module. But I kind of wanted to understand more just exactly how the module worked, and this seemed like a good opportunity to do that. So as I further got into this, my original plan was to actually create a working motor and to be actually send a signal to it and get the motor to shift and turn on, because I do have the motor apart over here, and I was going to hook it up to about a 9-volt battery, which would have simulated what I needed it to. Unfortunately though, during my experimenting and understanding this, the magnet that is used to basically give the signal fell and it broke. So we're going to be doing some drawings. I do apologize for my Picasso work because I apparently have the drawing skills of a 3-year-old, but it'll do for the job. So we're going to go over some basic stuff, starting with the circuit itself. So based on what I found as far as research and whatnot, this is pretty basic. These are all a form of Hall effect transistors, which is why it uses the magnet to actually figure out, let's see if I can get a little closer. It uses the magnet to basically send current through the transistors, and that's what will in turn cause it to shift and then cause the actual motor to kick on and shift to the angle that it needs to be. I also found basically in my research which transistors are supposed to have power and when. So that's another thing that we're going to be going over in the next couple of minutes or so. This is just my basic. So when I first started going over this, I literally sat here for a little bit and looked at where each individual line went, which actually was surprisingly harder than I thought it would be, because some of them actually go underneath the transistors. I don't know if you can see that or not. And it took me a little bit to figure that out and a lot of playing around. Unfortunately, I am not 100% on what these guys are yet. I haven't found that, so that's probably going to be a little bit later in the video, but we'll get there. And the other thing is these guys right here are actually where the pins are, so they're where your power is going to come in. Sorry, not even facing towards the angle, I'm facing towards myself, but this is where your power is actually going to come from and go to there, so we'll get to that. And then we're going to start. Alright, so the first one we're actually going to start with is going to be for low, which is the shaft angle is at plus 40. Now, as I'm looking at this, I realize that I've cut off part of my color key, so I'm just going to add in the letters real quick. What I'm going to do to try and help keep this as clean as possible with my sad little drawing here, which also, by the way, I should probably warn you, because I did each of these by hand, because A, it helped me kind of understand the circuit a little better, and B, my printer was running out of ink, but that's okay. So what I'm going to do is basically they're kind of like slightly different, you'll notice, but realistically it's all the same. Like, they're all the same lines going to the same places. And so what I'm going to do is I'm going to basically highlight each color so this way you can see where they are, and then I'm going to go through with a red and blue marker and actually show you where each angle has what going where. And so that's what I'm going to do. I'm also probably not going to go through the whole process each time. I'll probably speed it up a little bit just for the sake of the video. But just for this right now, just showing you, it'll be easier to do it this way. So starting with A. So A is actually going to have a high current.
So
and this is where it makes contact with the transistor. And then the other high current is going to be B. And this is where it makes contact with the transistor. And then my low currents are going to be C and D. So C. And so the way that these particular transistors work, and a transistor in general for those who don't know, is basically it's similar to an on-off switch, except it can also be kind of sort of on, I guess is a way to put it. So basically what it means is it actually kind of only allows a certain amount of current to go through instead of necessarily like the whole amount of current. And that's where it comes in with the highs and lows. And basically that would cause the magnet guy right here. It was a lot cooler when it wasn't broken. I do apologize for that. Like I said, I had a whole big thing that just didn't quite go like I had planned, but if I can get it apart here. And it was a lot of fun to play with when it was still together, because of the fact that it did actually almost resist until you got it directly in place, and then it popped right into place, and then it just stayed there. So that was kind of cool. But again, like I said, it broke, so we do what we can. And so what would happen is basically because of this, it would literally shift as a whole. But as you can tell, it doesn't want to sit right now. And it would shift around the circuit itself, which I probably should have had that in the picture. My bad. All right, so now we're gonna move on to the next one. Here, so from what I can tell, I believe these are grounds. I wanted to know for sure, but unfortunately, I didn't want to take this apart anymore without like breaking it. I don't know where to put it right now. Let's stick right there. So to actually see the backside was a little difficult. And like I said, I'm gonna do further research, and by the end of this video, I'll definitely have an answer for you. Even if it means taking it apart, but I wanted to actually do a video with this still in the picture assembled before I destroyed it. In the purpose of learning. So moving on. Okay. And now for neutral, we are going to have A is going to have high current, which is our green, I believe. Yeah. Okay. And then the other three are actually all going to be low current. All right, and that's going to give us 20. This is what's going to shift it into 4 high. Now for this one, our only high current is going to be to C, which is our purple line right here. To the transistor. And then the other 3 are all going to be low current. Alright, and that's what 4 high is going to look like. And like I said, I'm going to shift over to actually show you what the rest of everything looks like. So we'll move to that. Alright, so as you can see, I switched back to the larger markers because I feel like they're easier to see. And I also filled them out ahead of time for the sake of this video, because you don't need to see me coloring this whole time. So for this one, it's going to be 0 degrees for our shaft angle. And this is going to be what puts it into 2-wheel. And so we're going to start with A, which is our green. And this one's, oops, my bad, wrong color. This one's actually high current. Okay. And then we're to do our other high current, which for this one is going to be C. And now we're going to go into our low currents, which is going to be both B and D. Should probably label them next to the color coding chart so you can see it. Okay, and so this is what it would look like if it was in 2-wheel. Okay, so I ended up doing this a little backwards because I really wanted to get out of the way the main portion of the gear motor encoder, and before I actually started talking about where all the powers went and throwing in all the extra colors, I really wanted to focus on each individual color. So now what I'm going to do is basically just throw in the power and the reference voltage. Or not the reference signal. So yeah. So power is actually our number 2 pin, and it comes down and connects to all 4 connectors, or all 4 transistors. And then for our reference, it's going to start up here at the number 4 pin. And this one was probably the hardest to figure out because of the fact that it was so closely, I guess, alike some of the other ones. So it's like it was hard to tell that it went under, for example, transistor number 2 and came down this way. I actually ended up having to bend the transistor a little bit to kind of see behind it. It came down like this. It also went over like this. Like it literally went to all areas. So that's our basic, power and reference. All right, so now that we've gone over the power and the reference, I want to move on to actually the shifter motor itself and kind of how that works. So as you can see right here, I'll put the motor in later to actually show you it working in action, but it's consisted of 3 gears, well, 2.5 really. And what's going to happen is basically these are going to spin and it's going to cause this to shift that way, whatever degrees it basically commands. And then this is actually connected to the transfer case, and that's what actually shifts everything. And so the way this is done is, so the gear motor encoder is actually on the back of this shifter part. And like I said, I can show it better when it's actually together, and I'm not going to. So basically what happens is when the motor is turned on, so I'm going to move this out of the way and show you the actual motor itself, because it actually can shift in 2 different directions. As you can see right here, I put a little bit of nail polish so you can actually see it changing the different directions when I change the polarity. So this is positive, and then I flip it, and it turns back. And so basically what happens is when this is attached to here, so I'm going to try and do it on the camera and make no promises. I might have to cut it and go into it, but we'll see. And so basically when it's activated, I try not to drop shit. You can see the motor actually spin it. And that is in turn what will shift the transfer case into the different gears. Like I said, my original plan was to try and create an actual input-output to show you shifting into all the different degrees. However, that didn't quite go as planned. So, this works too. So I did eventually end up going and cracking open the back. Sadly, it was a little uneventful. Again, don't really know a whole lot about circuits. That was half the fun of doing this, is kind of getting to learn a little bit more about it. And what I learned is that there are single, double, and there was a third one, I don't remember what it's called, as far as circuit boards. And this is a single circuit board, so it's only on top. And so what I actually did end up finding out is that these are, in fact, the grounds. So for this part, what I've started doing, actually we're going to cross out those at the top because I screwed up on that. Just ignore those. But what we're going to start doing is basically figuring out, since we determined that these are grounds, I want to know where all the grounds go to. So that's what we're doing right now. Alright, so here's what I've basically learned by doing this. So for starters, I've learned that the first peg of all 4 transistors all share one ground. I've also learned that transistor 1 and 2 share a middle ground. I've also learned that they share, oh wait, no they don't. I've learned that the end peg has its own ground. This end peg has its own ground. I've learned that on 3 and 4, the middle pegs both share a ground. and I've learned that the end pegs both have their own ground. And so basically what I've learned from figuring all that out is just that depending on what type of sequence it needs to be in for what position it needs to be in is what needs to be activated in order to create the correct signal to produce the actual change, which was actually kind of cool to have that all connect in your head. I don't know if you ever had that happen before, but it's a little interesting moment. But anyways, moving on.
Alright, so that's it for me. I hope you guys enjoyed the video.